quadrilaterals now. So before we get into a specific one, I want to introduce you to all of them that we're going to talk about. All right, so this is the quadrilateral family up here, the old family tree. So let me introduce you to all the quadrilaterals we're going to talk about. First, at the very top is just our plain old quadrilateral. Only thing we know about it is it's got 4 sides and the interior angles add up to. The interior angles add up to. The interior angles add up to 360. Thank you. That's all I know about it. Nothing else. So if we are reading a problem at any point in this unit and it says quadrilateral ABCD, that's all I know. Interior angles add up to 360 and there's 4 sides. You guys can see that the quadrilaterals are broken up into 3 different families. 3 different families. The first family is the parallelogram family. The parallelograms. That will be our focus for the next 3 days, are the parallelograms. Now, that is the last time I write the word parallelogram. I have a shorthand for it that you can definitely use yourself. First, you remember the symbol for parallel before I show you my shorthand. It is, don't tell me 2 straight lines. Lines are always straight. What type of lines? Parallel lines. Killing me. Yeah, those are parallel, but that's not the symbol I'm going to use. 2 vertical lines. So you will now see me write parallelogram as this right here, parallelogram. Feel free to use it. Do not use your own symbolization, please. Within the parallelogram, there's special types of parallelograms. Let me first introduce you to Rosie, the rectangle. Also part of the family, Randy, the rhombus. And then finally, there is a golden child of the parallelogram family. Maybe some of you can relate. I definitely can. My poor sister. Susie, the square, the golden child. And we'll talk about that when we get to a square, why it's the golden child. So there's the parallelogram family. Why are all of these together and not in any of the other 2 families? Here's why. If anything in the parallelogram family has both pair of opposite sides that are parallel to each other. That's why. All right. Any of these 4 figures, they're opposite sides. Both pair of opposite sides are parallel. Now let's go to the next family. Let me introduce you to the trapezoids. First one, Tony, the trapezoid. And then we have the souped up version, version 2.0. Isaac, the isosceles trapezoid. Why are these 2 grouped together and not in the parallelograms or this last one we're going to talk about? Because they only have 1 pair of opposite sides parallel. Okay, that's it. They only have 1 pair of opposite sides. That's why they're not considered into the parallelograms. And then finally, we have the black sheep of the quadrilateral family, the outcast. Now maybe some of you can relate. And that is Kyle, the kite. And why is the kite all by itself? No pair of parallel sides. No pair. So these are all the quadrilaterals we're going to talk about. The next 3 days and basically a majority of your quiz are going to cover the parallelogram. All right, so let's start up. Today's all algebra questions. Tomorrow when you watch the video will be proofs with parallelograms. But we cannot do anything unless we know our properties of a parallelogram. And even before we get to the properties, you need to know how to label any quadrilateral. Last 2 units, we dealt with the triangle, yes? And when I said triangle ABC, you could throw A, B, C anywhere on that triangle. Didn't matter. Order didn't matter. Oh, now it does. Order now matters. So if I'm going to call this parallelogram ABCD, the order now matters. Here is what I mean by the order matters. Put A on any vertex you want. Go ahead. That doesn't, where we start doesn't matter. So you can put A anywhere you want. But from here, we now have to label the rest of the parallelogram clockwise or counterclockwise. We cannot skip diagonally. All right, we need to now label this either clockwise or counterclockwise. It's up to you, it doesn't matter, but we cannot do it diagonally. So A, B, C, D. Okay, good. That's any quadrilateral moving forward. Has to be labeled clockwise or counterclockwise. All right, let's start. There are 5 properties of a parallelogram. I don't need you to know them down cold today, but probably by Thursday. All right, probably by Thursday when we're done talking about it. First property you guys already know. Why was it in that one set of family versus the other 2? Because they had opposite sides that were parallel. So opposite sides parallel. Now why don't we throw those arrows on this diagram as well? That shows that the opposite sides are indeed parallel. So guess what's going to come back into play now? If you remember our parallel line unit, alternate interior angles, corresponding angles. They're all back into play because these lines are parallel. Period 3 could get 2 more properties on their own. Just saying. Just throwing that out there. What do you think? Throw something out, you're probably going to be right. They got at least 2 more. Josh?
Angle C and angle D are supplementary. Supplementary.
Wow. You're going real hardcore right away. That's one they didn't get. But it is a property. Save that. I want to put that at number 4. Save that. But good job. Yeah, good job. Even before that, anything else you want to tell me?
Angles that are like across from one another are congruent.
Opposite?
Yeah.
Okay, there. I can do that. Ready? Opposite angles are congruent. Yep. Angle A is congruent to angle C. Angle B is congruent to angle D. Yes, opposite angles are congruent to each other. Now I can get into what Josh just said because now take a look. Let's just say don't write this on your diagram because it's going to make a mess. Let's say angle A is 100, which means C is 100. Yesterday we learned how many degrees in a quadrilateral in the interior angles? 360, right? So already I have 200. So that leaves 160 degrees left for 2 congruent angles. So they got to be each what? 80 and 80. So this is what Josh is saying. Now, it just not only C and D, but D and A, D and B, B and C are all supplementary. We're going to call those angles consecutive. Consecutive angles are supplementary. Property number 3. Consecutive angles are supplementary. Good, good. You guys might be beating period 3 here. I need 1 more, though, to do it. 1 more. Think you're going to add on, Josh? Go ahead.
Is AB congruent to CD? Is that
correct? And so is
BC and AB?
Okay, so good. Opposite sides are parallel, so they also are congruent. Yes. So not only are opposite sides parallel, but opposite sides are congruent. Yes. So why don't we put some hash marks on those bad boys? Okay. And then the final property, I don't expect anybody to get because it's not even on your diagram. What did I just draw in there? That's a what? So we talked about it yesterday. Oh boy. Yeah, period 3 couldn't get it either. I was floored. What did I just draw in? What's AC called?
A diagonal.
Yeah, thank you, Aiden. Thank you for saving us all and from humanity here. That's a diagonal. All right, yeah? Connects two non-consecutive vertices. A parallelogram's got two of them. And let me help you out with this last property. When both diagonals are drawn in, there we go, they bisect each other. So in a parallelogram, diagonals bisect each other. They are not congruent. They bisect each other. That is it. And I'm not done yet. Little bonus, little challenge, honors kids. If they do indeed bisect each other, give me a vocabulary term for that point right there. Give me a vocabulary term for that point.
Midpoint BD.
What's this point called right here again? Gotta flip it, sorry. That's called the midpoint. All right, period through. It's like orthocenter. It's the centroid. This is a parallelogram, not a triangle, remember. All right, so it's not a point of concurrency. It is the midpoint of both diagonals. Not just one of them, both of them. All right, that's going to come into play here when we finish the notes today. So that's the midpoint of both diagonals. Again, I am not expecting to know these five stone cold today. Keep looking back if you have to. But by Thursday, we should be rattling them off. All right, let's use them. All we're going to do today is use them in algebra questions. All right, use them in algebra questions. So first one here is a parallelogram. Just so we're clear, this part of the diagonal is 10, and the other part here is 2x minus 4. With the properties we just wrote down, what am I going to do with the 10 and the 2x minus 4? Set them equal to each other. Yep. 10 equals 2x minus 4. And you'll notice the algebra I'm giving you is not tough because the most important thing I want you to get out today is the theorem we're going to write down. So I move the 4 over. I get what? 14 equals 2x. So hopefully all of us are getting x equals 7. All right, now let's talk about the theorem used. This theorem is going to be placed in your reasons column tomorrow when we start proofs and parallelograms. First thing we say is this was given to us as a parallelogram. So we're going to say parallelogram implies, we're going to use that arrow we've been using all year. And now you tell me what property you use. What property do we just apply using setting those two equal? Ian? So parallelogram implies, throw down the darn property you use. Diagonals bisect each other. So that's what I'm looking for where it says theorem today. All right. Again, I'm not trying to burst your brains here with the algebra. It's the theorem I want more importantly. So x here equal to, you look at your properties, x is going to be equal to 16. Yep. Y. Parallelogram implies, what property do we use here? Because in here we have opposite sides congruent. That's all I'm looking for. And this is going to go into our reasons column tomorrow if I needed to say those two sides were congruent. And there's only so much variation I can do here. So for the number 3, what are you going to do with 3x minus 2 and 4x minus 10? Set them equal, right? Don't give me the 180 business. That's for angles. 3x minus 2 equals 4x minus 10. I have more than enough confidence that you guys, be able to solve this. So x equals 8. And theorem used, parallelogram implies, same thing as number 1, diagonals bisect each other. Everyone good? Okay, now let's go to angles now. Let's go to angles, but here I'm going to let you and your group work together to find the numbered angles. Now, before you get going, we have all these properties in your mind. You don't have to use a property. You don't. Can I use vertical angles? Yes. Can I use linear pairs or supplementary? Yes. Can I say there's 180 degrees in every triangle? Yes. And also, hold on, I'm not done. And also, is it okay to find an angle that's not labeled? Yeah, it may get you to a numbered angle. All right, so just because I left an angle blank, you may want to find it because it may help you find a numbered angle that you don't know how to find yet. All right, so use anything you have to use, please. Use it all. Go. You got I'll give you about 3 or 4 minutes. Work in your groups to find the numbered angles, and no, you do not have to write a theorem for me. I just write the angle measure. And I'm going to show you guys something on number 7 and 8 that maybe some of you aren't seeing, but I need you to pick up. You guys don't have 7. Sorry, 5 and 6. That maybe you're not. You can still do it, but I'm just going to show you something that maybe some of you aren't seeing. Do not go to the graphing problem either. Do not go to the graphing one. We're going to do that one together. Again, remember, find a missing angle if you have to. That's not labeled. You'll get you to the numbered one.
Is any other angle 0? 3 and 4 is the triangle, right? People want to get. And that angle can't, only that angle can be 0. It might be the side.
I just got it.
Okay, let's keep moving here. Some of you guys are getting stuck, and that's great. And once I show you something you need to look out for, I think you'll be fine. 4 and 5 shouldn't have been an issue, right? Numbers 4 and 5. For number 4, you guys had angle 1 was 40 because it's supplementary. Angle 2 is congruent, so that was 140, and angle 3 is also supplementary, so that had to have been 40. Next one here, angle 1, 113 because it's opposite. Angles are congruent. Number 2, I have 45 degrees. And number 3, I have 22. Most of you guys probably, I assume, use 180 degrees in a triangle to get angles 2 and 3. All right, now, number 8, and this also applied to 7. Here's where you got to start watching out for. If you are given a parallelogram and at least one diagonal is drawn in, start looking for alternate interior angles. Why? Because remember, in a parallelogram, opposite sides are parallel. So if that's 22, that's why angle 3 was 22. Look for alternate interior. So you guys that got stuck on number 8, that 40 that was given can go here now because it's alternate interior. That 47 that was given can go here now because it's alternate interior. If at least one diagonal is drawn in for a parallelogram, start looking for alternate interior angles. Okay? Just a heads up. I know probably you weren't thinking about it, but start thinking about it. We want at least one diagonal drawn in. So what do I have here? Angle 1, I have 61 degrees. Angle 2, 72. Angle 3, $1.08. And then angle 4, 32 degrees. All right, so start looking for alternate interior angles, everybody. Start looking for them, especially when at least one diagonal is drawn in. Any questions up here now before we get to our last one? All right, take 30 seconds and graph parallelogram WX, Y, and Z, please. Go ahead and graph those vertices, connect them, and label the vertices as well. All right, now that we have it graphed, it's asking for find the coordinates of the intersection of the diagonals. And I am not Not interested in anybody doing this with the straight edge and looking at your graph and saying it intersects here. Okay? Because when I did that, I have no idea what that point is on the y-axis. No idea. Could it be 1.25, 1.5, 1.7? Who knows? All right, so we need to do this algebraically. And we talked earlier, when I draw both diagonals in, they bisect each other, right? They bisect each other. So the intersection of the diagonals should be the what? Midpoint of either diagonal, of either one. If we find the midpoint of xz, it's the same thing as the midpoint of wy. And guess who's not going to give you the midpoint formula? This guy. All right, do we really need to go back to our Unit 1 packets and look up the midpoint formula? What is it? Oh, crap, we're done already. We're done already. Minus, what is this, slope? x1 plus x2 divided by 2. y1 plus y2 divided by 2. So go ahead, take either diagonal. wy or xz, please take either diagonal and find the midpoint, because it'll be the same for either one. And that is the intersection of the diagonals. I am never going to accept just you looking at it. We've got to do it algebraically. And out of this, the intersection of the diagonals should be 0, 1.5, no matter what you found the midpoint of, which diagonal you did. Okay, all good? Please look at the bottom of your page. Let's go quickly discuss the homework tonight. Please see what needs to be done with number 21 and 37. 21 and 37 need to be done on legitimate graph paper, not doing this on your line paper. This is what I call a ghetto graph here. All right, that's not what I'm looking for. Actual line, actual graph paper. So if you need to borrow a slice, there's both back desks back there have graph paper on it. All right, go ahead and borrow a slice if you need to for the homework. All right, let's get going.